Hey there everyone, my name is Ngọc Nha Pham. I'm a student from Macquarie University, and today I'm gonna talk about how do we use conditional probability to predict the customer churn in telecom. So first of all, we need to know what is customer churn first. So customer churn, it refers to the loss of customers who discontinued their services with the company over a given period. It is also known as a customer turnover or customer attrition. And customer churn is measured as a rate, for example, the percentage of customer loss monthly or annually. So the churn rate is calculated by customer loss during the period divided by the total customer as star and multiplied by 100. So why does it matter? Why do we need the customer churn? Because the high churn, it indicates that dissatisfaction, competitive pressure, or poor services. And it is proven that reducing churn by just 5% can actually increase the profit from 25 to 95%. Impressive, right? So in telecom industry, the churn means the subscriber they cancel the phone, internet or TV services, or they switch to the other competitors. And there are many reasons behind that. For example, maybe the high cost, the poor network quality, or they have better deal somewhere else, the contract ending, or some kind of service issues, right? So in order to actually know how do we use the conditional probability to predict the turn, to calculate the turn, we need to know what's some kind of probability basics first. Because why probability? Because it helps us to quantify the uncertainty and make prediction. And in turn analysis, it models the likelihood of a customer leaving based on the factors, right? Alright, okay, so from this data above, which later on I'm gonna provide the link on Kaggle in the description, I will put into the Jupyter file notebook and see how it goes. Okay, so first of all, I need to import some library first. So yes, import pandas, SPD, I'll run this, and then I'll read the data file. So it's gonna be data frame equal to pd.read CSV. CSV, data name. It's gonna be like this one. Yep. And let's check the first a few rows first in the start. Yep. So okay. In the data frame, we have these columns, for example, customer ID, gender, senior citizen, the partner, so on and so forth. But in this case, in the contents of the video, we actually gonna focus on first of all the internet service and the terms, which is categorized as yes or no. Right? So first of all, before actually making the pivot table to group all of them together, we need to say whether is there any null value or not. Let's just check null. Oops, sorry. Right, is null got some. Oh, it seems like the data is pretty clean. And after that, I'll check on the column that we told earlier that we are gonna focus on, which is internet service. Let's say internet service, and you'll see whether it's any how many values there or not. Right? Alright. There are DSL, fiber optic, and no in the internet service column. I'll say, how about churn? Right, churn, and it's the same unique. Yep, and then there's yes and no, which verify that. Okay, so after this, I'll make a pivot table. Right, to actually from later on, we're gonna calculate the conditional probability from the table. Right, so it's gonna be pivot table equal to diagram part using the function pivot table. Right. And what is the row? The row should be internet service. Yeah, internet service. Column is the churn, which is the another one, right? And then the function should be based on the size, and we're gonna fill values by 0. Okay. Oops, something's wrong. Oops, let's double click. Okay. What else? Okay. Pivot table. It's not total, so I think I'm gonna just put a little bit total column in the pivot table as well. So I'm saying dot location of the total is equal to the pivot table dot sum, right? Dot sum, right? And then in the total on the bottom as well, So pivot table, oops, sorry, typo. Total equal to pivot table dot sum, and as is equal to 1, which means in the column, yeah. Oops, yep. And then let's see. Yep, that sounds pretty good. All right. So from the table I created in Jupyter 5 notebook before, I'll define some term first. So what is fiber optic? Fiber optic internet, it used light signal transmitted through thin string or glass or plastic to deliver data at extremely high speed. And DSL, which is digital subscriber line, it delivered internet via existing Cooper telephone line, splitting the line into channels for voice, data, and typically it is slower than the fiber optic, right? So the question is from the table. What is the chance that a DSL user will churn, or is a fiber optic user at higher risk? And in order to answer that, we need to know what is sample space. So the sample space is a set of all possible outcome in an experiment or scenario. So in the churn dataset, the sample space is all customer, which is 70, 100, and 43 customer. And each customer is an outcome, categorized by the internet service. For example, DSL, fiber optic, no, and then the churn, which is yes or no. Yeah, and the event. An event A, it represents a subset of the sample space, a specific outcome or group of outcome we're interested in. So I define the event A is a customer who churns. So A is equal to all customer where churns equal to yes, which is 1,869 customer. Complementary event. The complement of event A is the set of all elements that belong to the sample space but do not belong to A. So if A is the customer churn, so the complementary of A is the customer does not churn. It is very helpful because it helps us to calculate the indirect probability. For example, the retention rate is equal to 1 minus the churn rate, or we can just verify that A plus the complementary of A is equal to the total customer. And intersection of event. The intersection of two events A and B is the event that contain all of the elements that are common into both A and B. So if A is customer who churn, which is equal to 1,869, and B is customer who used the service DSL, which is equal to 2,421. So A intersect B is, these DSL customer who churn, which is equal to 429 customer, right? And mutually exclusive event. If events A and B are mutually exclusive, they cannot occur at the same time. So in other words, they don't have anything in common. So the event has DSL and has fiber optic, they are mutually exclusive because the customer, we know, they can't have both plans. So the intersection here is equal to 0. And united event, they are the event that contains all the elements that are either in A or in B or in both A and B. So for A is DSL user and B is fiber optic user, since they are mutually exclusive, so if I do A union B, it's going to be DSL plus fiber optic, which is equal to 5,517 customers. So the probability of event. Probability of event is the likelihood of an event A occurring. So PA is equal to the number of variable outcome divided by the total outcomes in the range from 0 to 1. So in the example of telecom, P churns is going to be the number here, the number of favorable outcomes, and then divided by the total customer, which is 1,743, yielding 0.265 or 26.5% chance a random customer churn, right? And the marginal and churn probability is very important as well, because marginal means a single event. So marginal probability is the probability of a single event ignoring the others one. So if the probability, if we want to calculate the probability of churn is no, which is no churn at all, we just take the number from this one, from the total, divided by the total customer. And we can do that for the probability of internet service is DSL as well, which is 2,421 divided by 4,843. And joint probability is another key thing as well. Joint probabilities is the probability of two events occurring together, which is PA intersect B, right? So P probability, so example, probability of DSL in turn is yes, is gonna be here 429 divided by 1743, which is 6.5%, right? And last but not least, the final one, conditional probability, which is the one we actually using to calculate the turn rate now, because sometimes we also interested in knowing the probability of in the event, given that another event has already occurred, and we call this a conditional probability. So for example, if I want to calculate the probability of turn, given the DSL service, internet service type, so P churn is equal to yes, given DSL is equal to P churn equal to yes, intersect of DSL divided by PDSL, which is equal to this one. And we can do the same to P churn is equal to yes given fiber optic, and P churn equal to yes given no internet as well. Okay, so in order to verify what we have done so far using the conditional probability to calculate the probability of turn given the internet service type, I'm gonna verify them and validate them on the Jupyter notebook and plot to see how it goes, to visualize it to make it better. Yeah, so it's P churn is yes given internet. Yeah, it's very quick. It's gonna be from the group by function, and we're gonna group by the internet service. Yeah, and with churn, oops, what if I got a bracket with churn, and I'll use the lambda function to make it quicker. Lambda or x equal to, so that x equal to yes, and then I'll apply the mean. Yeah, oops, sorry. I'm gonna run this and I'll see how it goes. P churn, and we're gonna plot it. We're gonna visualize it to make it look better. And we're gonna plot. I'll use the bar plot above. Kind of use bar. Color. I'll use sky blue. I like sky. Okay. And what is the title? I'm just gonna PLT plot. First of all, I'm gonna do the label first. P turn equal to yes. Oh, this is okay. And then I'm gonna say PLT what title is probability to give an surface type, yeah. And then PLT dot ylim to make the boundary between 0 and 1. So we're gonna look better in the visualization, yeah. Okay, all right. So yeah, from the table we created before, from the conditional probability we created manually, we calculated manually as well, and from the graph above, what does it mean? So the result is fiber optic user, they have the highest conditional probability of turning, which is 42%, and is nearly double of that DSL and over 5 times of that customer with no internet service. So this is very interesting because fiber optic, they have a very premium service at high speed capabilities, even higher, even faster than DSL. The customers who use fiber optic, they are at the significant risk of leaving, and this might suggest some potential dissatisfaction because of, for example, the contract or some kind of slow internet or some kind of interruption or so on and so forth. And what should the telecom company do? First of all, they need to prioritize the retention effort for fiber optic user. But I'm not gonna discuss yet in this video because this video we're gonna primarily focus on using the conditional probability to actually calculate the probability of turn, the turning rate, right? So yeah, that's all for today. Thank you for listening and hope you guys see you guys in the next video. Thank you.